So how do you find the distance between 2 points? You call one of the point x1, comma y1, and here you can call it x2, y2. Right? Can I call this x2, y2? Yes. Then just call the other one x1, y1. So what's the order pair of A? It's 2, comma 7. What about B? 1, 2, 3, 4, 5, comma 3. So I'm going to first show you how to find the distance using the distance formula. So let's plug it in. So distance equals to square root of, what's x2? 5 minus x1, 2 square plus y2. y2 is 3 minus, what's y1? 7 squared. And you just evaluate it. So square root of, what's 5 minus 2? 3 squared plus, what's 3 minus 7? Negative 4 squared. Again, when you plug into a calculator, you can do parentheses negative 4 squared, or if I were you, I'll just put what? Positive 4 squared, because negative 4 squared equals to positive 4 squared. And that way, you can reduce the chance of making a mistake with negative. So 3 squared is 9. 4 squared is 16. So you have square root of 25, which gives you 5. Yeah. So the distance is 5. So that's one way to do it. If they give you a graph, you can also find the distance in a different way. How? If you just go ahead and find, basically what they did for xy minus x2 is to find this distance. X distance, which was 3, which you can easily count, right? 1, 2, 3. The y2 minus y1 was basically finding this distance, which you can easily count it too, right? Which is 4. Doesn't this form x and y form a right angle? So this is right triangle. Isn't this 3 squared plus 4 squared equals to 5 squared? This is Pythagorean theorem. Distance formula is just like a Pythagorean theorem. They just use the Pythagorean theorem to write for D, which is the C. So we took a square root of it. And if it's 3, 4, 5, without showing me much work, you should know the distance is 5. Right? So for this one, it was much easier to just do it on the graph, right? But make sure you know how to do it both, because they're not going to always provide the graphs. Okay? Number 2. So this one, which way do you want me to show you? Should we just draw a right triangle on the graph? Yes. So then you find the x distance, which is x minus x2, y distance, which is y2 minus y1. And what do? Just count it, right? So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what do? You should already know this ratio, right? 3, 4, 5 on Pythagorean multiples. The other one is 5, 12, and 13. These two, you don't have to show me work. You can just memorize them. You see 5, 12, then it should become 13. Check it. It's 5 squared plus 12 squared. Square root of that become what? What's square root 5 squared plus 12 squared? 169. What's square root of 169? 13. So again, these two are commonly used. Just memorize it. 3, 4, 5 is easy. 5, 12, 13. It's not too bad. What about the third one? This one, there is a graph, but this time let's practice using the distance formula. Okay? So here's x1, y1, x2, y2. Again, it doesn't matter which one you call point 1 and point 2. So distance is square root of x2, 3 minus 7 squared plus y2 minus y1, 2 minus 4 squared. So it's square root of 3 minus 7 is negative 4. Negative 4 squared. But again, I'm going to just put 4 squared because it becomes the same thing. 2 minus 4 is negative 2 squared, which is same as 2 squared. I'm going to just make it positive. So I get square root of 16 plus 4, which is square root of 20. Now we plug into the calculator. What's square root of 20 rounded to the second decimal place? So it's approximately 4.7. 4.47. Yeah. So next page. So it's kind of same thing. You just gotta be careful when you're subtracting negative. You are basically what? Adding the number. Yeah. So let's do one more together, and I'll let you try these on your own. Y1, x2, y2. So distance is square root of x2, 34 minus 4 squared plus y2 minus 5 minus 15 squared. So I get square root of 30 squared plus negative 20, but I'll just write 20 squared. So it becomes what? 900 plus 400, 1300. So what's square root of 1300? Hmm? 0.06.